In this lesson, I'm introducing students to the power rule of products, quotients, and other powers. And they previously have been exposed to the power rule of exponents with products. And so they've already learned that they could expand out the first problem. So most of them, if they don't remember the shortcut rule, they will just show the first expression being multiplied times itself 3 times, and then the second expression being multiplied times itself 5 times. But then we talk about, well, that's really long when you start really taking those exponents higher to expand out and see how many variables of each of like bases are being multiplied. And so it's easier to use this. That is one advantage of the power rule, the shortcut for the power rule of exponents. So you would have x to the negative 6 if you apply the power rule, y to the 9th, z to the 12th, and then you would have that times x to the 30th when you multiply 5 times 6, y to the negative 25th, and z to the 0 power. And so now when you multiply, you would add the exponents now, because that's how many x's are being multiplied when they have like bases. So it would be x to the 24th, y to the 9 plus negative 25 is going to be negative 16, and then z to the 0 power is just 1. And then you ask them, is it simplified? We'll know one of the rules of being simplified is that you can't have any negative exponents. So we have to change the location of y to the negative 16th. If we change its location to the denominator, that becomes y to the positive 16th. So the answer is, final answer is x to the 24th in the numerator divided by y to the 16th. The next one is a power to power, and I really emphasize, well, if there's a number already in parentheses, the integer negative 3 is being taken to the third power, and so you still leave parentheses around it when you're taking it to that third power, because that's really going to be important when you have an even exponent that would actually make it the number positive. And then you have a to the 6th, b to the 3rd, and then d to the 12th, and we talked about how you still apply the power rule, multiply the exponents, because if you expanded it out, it would still be the d to the 4th being multiplied times itself 3 times in the denominator. And then you simplify it, that's going to be negative 27 when you multiply negative 3 in parentheses to the third power, a to the 6th, b to the 3rd, d to the 12th. Is it simplified? Yes, all the numbers are simplified. There's no negative exponents, and there are no like bases. And then the last one is a negative exponent, which I'll show more in my teacher notes of different ways to apply the negative exponent. But if we just apply it the way it's set up, you would have 4 to the negative 1, x to the negative 1. If you apply the shortcut rule for the power rule, y to the negative 1, divided by 2 to the negative 1, x to the negative 3, and y to the positive 2. And then you start simplifying it. Well, I can exchange places with 2 to the first power over 4 to the first power, which would just be 2/4, which will reduce to 1/2 in a minute. And then the x's, I also could exchange places to make positive exponents, or I could have subtracted those exponents with the quotient property. I'll just go ahead and switch places and make the exponents positive. And then I could move y to the first to the bottom also. And now if I simplify that, that's going to simplify to 1/2. One of the x's divide out, and you're left with x squared. Or you could have subtracted the exponents 3 minus 1, same thing. And then y to the 3rd is in the denominator. So there's several different ways to do these problems, and I'll emphasize more of those different methods throughout the lesson.